Hello everyone. In this video, we are going to understand about the banker's algorithm, and specifically we will be talking about the safety algorithm, which is inside the banker algorithm with the help of example. So let's start. So as we have discussed in the previous video, that banker algorithm is a deadlock avoidance algorithm. And what is deadlock avoidance? This we have discussed in the previous video. You can check the video in the video description below in the operating system playlist or in the I button also here. So this banker algorithm, which is a deadlock avoidance algorithm, it tells whether a given system or the OS in its current state is in safe state or not. Okay, and it also tells if a particular process asks for some resources from the operating system, then whether that operating system will fulfill the request of that particular process or not. Okay, so these two things are told by the banker's algorithm. So the main thing in the banker algorithm is finding the safe state. Okay, and what is safe state and what is unsafe state, this again we have talked in the previous video. Okay, so safe state means if we have some particular order of execution in which the processes can execute it. So what is safe sequence? So it is just an order of completion of processes or order of execution of processes in such a way that they do not stuck in the deadlock. And what is unsafe state? It is a state if we are not able to find any order of completion of all the processes which are given to us. That is, the processes may go into the deadlock state. Then we will say that our OS is going into the unsafe state, and then we will not fulfill the request of the various processes. Okay, so this is the example that we have discussed in the previous video, in which we discussed the banker algorithm in an informal manner. So in banker algorithm, we are given the various processes. Their maximum need is given to us. Maximum need means how many number of resources they will be using in their lifetime. Okay, so P1 need 3, P2 need 5 resource, and P3 need 7 resource. So resources can be like printer, hard disk, CD-ROM, anything. Okay, so here we can assume that, let's say we have the printer. So P1 need 3 printer, P2 need 5 printer, P3 need 7 printer, right? And another thing that is given in banker algorithm is the allocated number of resources. So P1 is using 0 number of resource, P2 is using 3 resource or 3 printer at this particular point of time. It needs 5 printer, but currently it is using only 3 printer, right? The same way P3 is using 4 printers as of now. In banker algorithm, another thing that we are given is the available number of resources. So available number of resources are 2. That means after allocating all the resources to the processes, we are left with 2 resources or 2 printers. So banker algorithm says whether we are able to fulfill the request of all these processes with this available number of resources or not. That means in the future, P1 may need 3 more printer, P2 need 2 more printer, because 5 printer it needs, 3 printer are allocated. So 5 minus 3, it will be 2. 2 more printer it will be needing into the future. The same way it goes for P3 process, right? So we discussed that whether we will be able to complete all the remaining need of all these processes with these 2 printers or not without going into the deadlock state. And that order of execution of all the processes without going into the deadlock state, it will be a safe sequence, right? So we discussed we have the 2 safe sequences, P2, P3, P1, or it can be like first we complete P2, then we can complete P1, and then we can complete the request of P3. So let's now see the banker algorithm in a formal way. So basically, banker's algorithm consists of 2 algorithms inside it. One is safety algorithm, another is resource request algorithm. So safety algorithm, it will be telling us whether the system or the OS is in safe state or not at current point of time. Okay, and resource request algorithm, it will be telling us that if a process asks for certain number of resources from the OS, whether we can grant that request of the process or not without going into the deadlock state. Okay, so resource request algorithm, actually it also uses safety algorithm. Okay, so that's why safety algorithm is the basic algorithm inside the banker algorithm. So in this video we will be seeing that what is the safety algorithm and how it works with the help of example. And in the next video we will be seeing resource request algorithm. So in the previous video we have discussed this example, right? And we saw that these were the safe sequences. Okay, so actually at that time we had applied the safety algorithm itself. Okay, but I had not introduced safety algorithm as such in a formal manner at that point of time, but we had applied safety algorithm at that point of time also. Okay, so in this video we will be seeing formally how this safety algorithm works with a new example. So let's understand our banker's algorithm, in which we will be discussing safety algorithm, right? So in the banker's algorithm, we are given some of the things in the questions as the input, right? And what are those things? So we will be given number of various processes, then the maximum need of each of the process, then how many number of resources that are currently allocated to the processes at particular point, and how many number of resources we are available with in our computer system after we have allocated these requests, right? So let's understand how the safety algorithm works. So this algorithm says you have to take two arrays. One is the work array and one is the finish array. Okay, and here you can see that n is the number of processes in our system, m is types of different resources. Okay, so what is this type of different resources? So here in this example we have seen that we were talking about the printer, right? We have one resource, only one type of resource. Okay, we have the printer. So we were saying that P1 need total 3 printer, P2 need 5 printer, P3 need 7 printer. Okay, so here actually we have only one type of printer. That means the value of m will be 1. Now in this video we will be applying banker's algorithm or the safety algorithm in this question. Okay, so here you can see we do not have only one resource. Okay, or you can say we do not have only one type of resource. We have 3 types of resource. Here you can see R1, R2, R3. These are different types of resource. What is different type of resource? That means let's say R1 is telling that printer, R2 is telling we have CD-ROM in our computer, R3 is telling let's say we have tape drives, okay, or magnetic tape drives. So that means P0 need 3 types of different resources. P0 need 7 printers, 5 CD-ROMs and 3 tape drives. Okay, the same way P1 also need some particular amount of resources of each of the 3 types. Okay, so here we have value of m equal to 3 because we have 3 different types of resources: printer, CD-ROM and the tape drive. So this is meant by types of the resources. So this way we have created the work array and finish array. The same way we have the available array. So here you can see we have 3 arrays. Available array will be telling us that how many number of resources are available of each type. Okay, so let's say value of m is 3, then the available array will be of 3 size. Okay, available array will be of 3 size. Okay, and each box of the available will be telling me that how many number of resources of each type are currently available. Okay, how many printers are available, how many CD-ROMs and how many tape drives are available, right? The work array will be actually equal to the available array only. Okay, initially work array will be just copying everything from the available array. Okay, so here you can see we will be initializing the work array equal to available array. Okay, and this is just a pseudocode, so do not just say okay I have not written a for loop and everything. Okay, this is just a pseudocode. So whatever thing is in available array just take into the work array. Okay, next thing we have to initialize is finish array. So finish array is actually an array which contains only boolean values like true and false. Okay, so initially we will be saying everything inside finish array will be false. Okay, from I equal to 0 to 1, 2, 3 till last n minus 1. Okay, so finish array will be equal to total number of resources which are available in our system. From 0 to this will be like n minus 1. And what is the use of this finish array? So finish array just tells me that which process has been completed or request of which process has been fulfilled. Okay, so initially everything will be false because no process request has been completed. When a process request is going to be completed, then that false will be changed to true. Okay, that we will see. So after initializing the work array and finish array, we will go to our main algorithm. Okay, now here what we will do, we will actually do this thing repeatedly again and again, again and again, again and again. Okay, till we just complete the request of each and every process, or let's say we can stuck into something like unsafe state also. So just the idea is we have to repeat this thing, and after doing these things we will go to the step number 3. Okay, and after this second step will be completed completely, then we will finally go to this fourth step. Okay, so this is the idea behind this algorithm, or this is the just a working of this algorithm. So what we will do, we will come to our second step and we will find our index I which can satisfy these two conditions. What are the conditions? We will find a process which is not completed as of now. So we will come to the second step and we will find a process for which these two conditions are true. What are those conditions? So if that process is not completed, we will find that process, and we will also check the need of that process should be less than the work. So if that process is asking for the resources which are equal to available resources or which are lesser than the available resources. Okay, so the need of that process should be lesser than this work or equal to work, and that process should not be completed as of now. Okay, so if these things are true, then we will say, okay, we have found that process, or we have found the index of that process. Then we will go to this third step, and this line or meaning of this line we will see later in the example. So this is actually granting the request of that process, and then it is saying, okay, that process has been finished, so just change the status of the finish array for that particular process to true. Okay, and after this we will again go to the second step, and again we will find a new process whose finish of I should contain false, and need of that process should be less than the available number of resources at current point of time. Okay, if we find that process, again we'll go to the third step. We will allow, or we will fulfill the request. Then we will say, okay, that process has been completed, mark that array index as true, and again we will go to the next process to check whether that process fulfill these condition A and B. Okay, now let's say if we come to a point where we are not able to find a process for which these two conditions are true, and these two conditions should be true simultaneously. Okay, you can say in programming wise these are like AND. Okay, this should be true and this should also be true. Okay, so if we are not able to find any such I for which these two conditions are true, then we will simply come to the step number 4 and then check this thing. If the complete finish array contains all the true, okay, true, 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 then we will say, okay, my OS or my system is in safe state. But if at least one of the box of the finish array contain false, okay, that means all the boxes does not contain true, then we will just come to else and we will say our OS or the system is in unsafe state. So let's quickly go to the example. So in this video, we have taken a bigger example where we have different types of resources, right? We have 3 types of resources. Okay, so we can say, okay, R1 is like printer, R2 is like a CD-ROM, and R3 is depicting my tape drive. Okay, and each process is asking for certain number of resources of each type. Okay, P0 is asking for 7 printer, 5 CD-ROM, and 3 tape drive. So this is the maximum need of each of the processes. So that's why I have written multiple types of resources. We have 3 different types of resources. Okay, and multiple instances mean we have the printers available, right? But we have not only one printer, we have many printers. You can say we have let's say infinite number of printers. Okay, so that number of printers which are available, that is like instance. Okay, so that means you can say P0 need 7 instances. Okay, 7 instances of the printer. Okay, P0 need 5 instances of my CD-ROM. Okay, and P0 need 3 instances of the tape drive. Now another thing that is given to us is number of available resources in our computer system. So we are left with 3 printers, 3 CD-ROM, and 2 tape drives. And the question is asking whether this system represents a safe state or not. Okay, so if we are able to complete the request of each of the P0, P1, P2, P3, P4 with these available number of resources, then we will say, okay, we are in safe state, otherwise not. And what request we have to fulfill? So we have to complete this request. That means P0 is going to demand 743, this number of resources in the future. P1 may need 1, 2, 2, these number of resources in the future. So we have to tell whether we will be able to complete all these needs with this available number of resources or not. This is meant by safe state or the unsafe state. So first we have to do our basic work. So here M value is 3, that is the multiple type of resources we have available are 3, and the number of processes we have 5 from P0 to P4. So we will initialize this work array. So we will initialize this with the available array. Available array has 332. So work is equal to 332. So I'm not showing this with the help of array, like this has 0 index, this has 1 index, this has 2 index. Okay, just for the simplicity. Okay, so you can assume this is at the 0 index, this is at 1 index, this is at 2 index. Okay, finish array contains all the values as false, and finish array will be equal to total number of processes. Okay, so no process has been completed initially, so everything contain false, false, false. Okay, now after this step, the next step is we have to find a I such that these two conditions are true, right? And after that we will be allocating their request. So I have written the finish array here, okay, just for the better clarity. So this is 0, 1, 2, 3 and 4. Okay, everything contains false. So here you can see we will start from the index number 0. So you can say this is 0 index, this is 1, 2, 3 and this is 4th index. Okay, so you can say this is your I. Now you start from the first process, that is P0 process, and check two conditions. So here you can see we have to check whether we will be able to complete this request 743 with these available resources. So here you can see first we have to check our finish array. So finish array for this 0th process is false, right? So this is okay. Okay, and now we have to check the second condition, whether our need is less than this work or not. So our need for the I equal to 0 is, for I equal to 0 we have the need as 7, 4 and 3. And what is the value of the work? It is 3, 3, 2. So 3, 3, 2. So this should be lesser than this or equal to this. So what does it mean? Just see it carefully. So it means this 7 should be less than 3, 4 should be less than 3 and 3 should be less than 2. If we have this thing fulfilled, then we will proceed forward, otherwise not. Okay, so here it is asking for 7 printer, but we have 3 printer available. Okay, this is work and this is need. So 7 is not less than equal to 3, right? So what we will do, we will just say we will not proceed forward. Our second condition is true. Our need is not less than 1. Okay, so although 4 is also not less than 3, 3 is also not less than equal to 2. Okay, but we will not check this 4, 3 with 3, 2. Why? Because in Banker's algorithm, it is must that all these 3 things of the need should be lesser than all these 3 things. Okay, if any of the thing inside this need array is greater than any of the thing inside work or the corresponding thing inside this work, then we will simply say this condition is false. So here we just got false in the initial thing only. 7 is not less than equal to 3. So we will say okay, for I equal to 0 we will not proceed forward. This is our not desired process for which our condition can be true. So what we will do, we will now proceed with the next process, that is I equal to 1. Okay, so P equal to 1, here again we will check this thing. Okay, so for I equal to 1 we will say okay, first check the finish array status. So finish array status for this I equal to 1 process is false. That means this has not been completed. Okay, so this can be candidate for our algorithm. Now we have to check whether our need is less than this work. So here you can see our need is 1, 2, 2 and our work is 3, 3, 2. So we have to see this condition. So 1 is lesser than 3. Okay. 2 is less than this 3. Yes. 2 is less than or equal to 2. Yes, 2 is equal to 2. Okay, so that means need is less than equal to work. This condition is true. So both the conditions are satisfied. So what we will do, we will grant the request. Okay, so grant the request means this request will be fulfilled. Okay, so this 1, 2, 2, this will be given to the P1 process. Okay, so currently it has 200 this number of resources. If we grant this 1, 2, 2, then what will be the value of the allocated? So allocated, it will be equal to 200 plus 1, 2, 2. So 2 plus 1, 3 printers have been given to P1. 0 plus 2, 2 and 0 plus this 2, again 2. Okay, so 3 printers, 2 CD-ROM and 2 tape drive have been given or granted to the P1 process, right? So this is allocated. Now what will be inside this need array? Because this has been given to this P1, so now everything will be 0 because everything is given to the this P1. Okay, P1 is been allocated 3 2 2 2. That is all the maximum need of P1 has been granted, right? Now after we have completed the request, that is after we have fulfilled this need, then what will be the value of the work? That means how many resources are currently available with the computer system. So work will be actually, we have 332, right? We have 332, right? But we have given 1 2 2 from this available number of resources, or you can say, okay, we have given from this work. Okay, so from 332 we have given 1 2 2. So what will be left? 2 minus 2, I'm writing here 0. 3 minus 2, it will be 1, and 3 minus 1, 2. So we are left with 2 1 0, these number of resources in the work. Okay, so these are the available number of resources. Now safety algorithm or the banker algorithm says, let's say at t equal to 1 p.m. this request was fulfilled, this need thing was fulfilled, and P1 has this number of resources. Now after some point of time, let's say at t equal to 2 p.m. all these resources which are held by the P1, they will be released. Okay, they will be taken back by the computer system. Okay, P1 will release all the resources after using them. Okay, so after P1 release all these resources, how many number of resources it will be giving to us? It will be giving us 322. Okay, because all these resources were allocated to it. So after 322 were returned by the P1, then what will be the content of this work? So this work will be equal to 210 are the current value of work. After it returns this 322, so it will contain like 322 will be added, and it will be 2 213 and 325. Okay, so 532, this is the final content of work array after P1 releases all its resources that are allocated. Okay, and after this we will say this false will be changed to true because it has been completed, its request has been completed, and we are done with P1. Okay, so now before moving forward, let me tell you one important thing is, after we said okay, this need is less than work and we have to grant the request of this P1. Okay, and after that we grant the request, and finally we said okay, it will release the resources and work will be equal to finally 532 again. Okay, so this all things that we have subtracted here, then we have added here, so all these things can be actually minimized, this calculation can be minimized. Okay, and there is a logic behind this. So what do I mean actually? So here you can see what I am trying to say is, when these things were granted to this P1, so what we did, this was the work array. Okay, 332 minus we did need. Okay, so it was 332 minus 122, this thing, so we were left with 210. Okay, with this work array, and after this P1 gives back all the resources, then what we are doing, we are saying okay, 210, that means this thing plus all the return resources, again we are getting 532. So now instead of this, what we can do is, here when we were initially having 332 resources, we are just adding the allocated number of resources, and we will get this final content 532. See, so this is our work plus allocated number of resources. We just added allocated number of resources with this work, we get 532. So actually idea behind this thing was this, that is we are doing this thing, okay, plus this thing. Okay, because this thing actually, this thing only, right, 210 plus this thing. So actually if you go in so actually if you do some practice by yourself, you will see okay, we were actually first subtracting this thing. Okay, and with this thing our work array was getting minimized. Okay, and after that we were saying okay, just add this thing. Okay, instead of this, what we can do, we do not subtract anything from work array, we are saying just add this thing into the work array, then also we will get to the same result. So actually we will be doing this thing directly, work plus allocated, we will be getting this answer instead of this. Okay, so by practice you can see that these things and these things are both are same. Okay, So here I have written everything in the clear manner. So for I equal to 0, for this we had the finish 0 equal to false, but our need was greater than 1. Okay, so we said okay, we are not proceeding with this thing. When we came to I equal to 1, okay, then we say okay, finish was false, need is less than work. Okay, so we are directly saying work equal to the work, that is this one, plus allocated thing. Allocated thing is 200. So that means 532 we are getting. Okay, that means after returning all the resources we are getting 532. Okay, so this is doing like we are granting the request and then we are taking all the resources back. And finally we are saying finish of 1 is true. That means this is true, right? Now after this process is completed, so we are just saying okay, just cross it, or we are saying finish array contains true. Okay, now the algorithm will say okay, you can proceed forward. Okay, now you check the P2 process. Okay, you can also check P3 process. Okay, after P1 you can check P3 if we are able to fulfill the demand of P3 now. Okay, you can also proceed with the P4 also. Okay, or you can say after P1 I will just see whether I am able to complete the request of P0 also or not. That means after completing the request of a particular process, you are free to go with any of the process. Okay, it is not like you can go in this simple in this manner. Okay, but while we are doing our particular example, we can go to like in one manner. Okay, we will go to this way. That means after we found P1, now we will check for P2, then P3, then P4, and after P4 is over, again we will go to P0, then P1, P2, P3, P4. Okay, in this manner we will be going. Okay, so you will understand later in this video that what I am talking about. Okay, so I equal to 1 is finished. Now let's move forward. So we can say our work array is now contain 532. Okay, and this finish box of the 1 contains true. Okay, so my save sequence contains the first process as P1. Okay, so I am just doing this angle bracket. Okay, this is just not the need. You can just use this angle bracket if you need. Okay, this is not a convention. You have to use this angle brackets. Okay, so P1 is the first process to get complete in this save sequence. Now let's proceed forward. Now let's check for the I equal to 2. So for I equal to 2, you can see the finish of that 2th process is false, but need is not less than work, it is greater than work. So what does it mean? So here you can see need of the 2th process is 600, right? And what is the value of work? 532, right? So 6 is greater than 5. Okay, it is not less than equal to 5, right? So we will say need is greater than work, it is not less than equal to work. So our less than equal to condition is false. So we will not so that means we will not be able to fulfill the request of P2 because this request is actually greater than our currently available number of resources. Okay, all the 3 things should be fulfilled. Okay, although 0 is less than 3, 0 is less than 2, but we have to see all the 3 things should be less than equal to all these 3 things. Okay, so we will say okay, we are not able to go with P2. Okay, we will not be able to complete the request of P2. So now what we will do, we will go to the next I. So for I equal to 3, we have to check finish of 3 is false. So here you can see finish of 3 is false. Okay, finish of 3 is false. Whether the need of this I equal to 3 process is less than work. So here you can see need of this PT process is 011, and the work is 532. Work contains 532. This is the available number of resources. So 0 is less than 5. 1 is less than 3. 1 is less than this 2. That means every 3 things, they are less than all these 3 things. So both the conditions are true. So that means we will say 011 will be granted. Okay, so 011 will come to this here 011. Actually this will happen. So it will be like 2 plus 0, it will be 2, 1 plus 1 2, and 1 plus 1 2, 2 2 2. Okay, so it will be given. So P3 will contain, so P3 will have now 2 2 2, this number of resources, that is actually equal to maximum need, and after some point of time it will be taken back. Okay, or P3 will release. So I'm simply doing work equal to work plus this allocated, as I have told you earlier. Okay, that's why I'm doing this simple thing. So after doing this thing, 5 plus 2 7, 3 plus 1 4, 2 plus 1 3. 743. This is total number of resources that I am available with in my computer system after the request of P3 has been fulfilled and it has returned all these resources. Okay, so now P3 is also over. So I will simply say finish of 3 is false. Finish of 3 is true, not false. Okay, so it is true, 1 and 3 are done. Now let's proceed with the I equal to 4. So for I equal to 4 again, finish of 4 is false. Okay, and need is also less than work. Here you can see need is 431 and work has now been changed to 743. 4 is less than 7, 3 is less than 4, 1 is less than 3, right? Both the conditions are true. So again we will grant this, then all these resources will be taken back. That means my work array finally will contain 743, that means the current one, plus allocated number of resources is P4. 022 will be added. 745 is the final value of the work. Okay, finish of 4 will contain true. Okay, so this is also done. So that means after P1, what is the next process that was completed? I equal to 3, that is this P3. After that P4 is also done. My safe sequence contain P4. Okay, this is the order of execution of all the processes. Okay, now after I equal to 4, what we have to do? There is no more processes after P4. There is no P5. So again we will check. Okay, any process that is having finish value as false, just check those processes. So I will come again to this P0. Okay, I will check first. So I will check P0. Okay, so I will come to I equal to 0 and I will say, okay, are you finished or not? So I equal to 0 process, it will say, okay, I am false. I am not yet been completed. My request has not been fulfilled. So safety algorithm will say, okay, just let me check. Your need is less than work. Yes, 743 is less than your currently available resources. That is 745. 7 is equal to 7. Okay, 4 is less equal to 4. Okay, 3 is less than 5. Okay, need is less than work. So work equal to work plus allocated. Allocated means this thing 010, and I will get 755 in the result. So my I equal to 0 P0 process is also finished. So I will say finish of 0 is true. Okay, so this is also over, right? Now after that I will go to P1. Okay, but P1 is already completed. Okay, the finish of 1 is not false, it is true actually. Okay, so I will say, okay, you are already finished, so I will not come to you again, right? Now after this I will go to P2. Okay, so for P2 it is not finished. So for P2 finish of 2 is false, need is less than work, so need is 600. Okay, 600 is less than 755. Okay, all the three things are lesser than this. So what we will do, we will say work equal to work plus allocated. Work is 755 and allocated is 302. Here you can see 302. Okay, after adding I got 1057 as the work content. Okay, the content of the work array will become 1057, and I will finally say finish of 2 is true. That means this second process, P2 process, is also finished. This is true. Okay, okay, now after this there is no process left that has not been completed. Okay, 3, 4, okay, every process has been completed. Okay, so now our algorithm will stop. You can see after P4 the next process that was completed was P0, and then this was P2. Okay, so this is my safe sequence. So as I have got one safe sequence in which I can complete the request of all the processes. So as I am able to find one safe sequence in which I can complete the request of each and every process, that means I have come to a safe state. Okay, that means after doing all this rough work, banker algorithm came to know that it is in a safe state. It can grant the request of each and every process. Okay, so it will say, okay, I'm in safe state. So you can again rewind this video and you can go through this video again to get the better understanding of this algorithm. Okay, and these are those safe sequences. We have found this safe sequence, but these are the other 5 safe sequences. So let's say in any of the exam like GATE or the other exam, they ask that tell us how many number of safe sequences are present. Okay, how many total number of safe sequences are present. So what you will do, you have to give the answer. Okay, these are the safe sequences. Okay, these are 6 safe sequences, okay, that are available or that can be possible with these state. Okay, so how it is possible, I will just tell you one safe sequence. Later you can find the other safe sequences also. So here you can see, after we completed the request of P1, our work array was 532. These were the available number of resources. Okay, so after P1 we have 532. So now after P1, can I complete the request of any other process other than P3 with this 532 number of resources? Because I said after P1, it is not the restriction that you have to go with the P2, then P3, then P4. You can go to P0 also, or after P1 you can just go to P4 also to check whether I can fulfill the request of P4 or not. Okay, so in that way, with 532, can I complete the request of any other process other than P3? So here you can see this was P1. Okay, so you have to check the need of every process. So here you can see this 743 is greater than 532. So I cannot complete the request of P0 after P1. Now for P2, again need is greater than this 532. Again P3, it was okay. For P4, this 431, it was less than this 532. That means after P1, I can go with P4. Okay, so what does it mean? I complete the request of P1 and after that I can go with P4. So that means if I add this 002 with 532, what will be my value of the work after this P4? So it will be 5, then 3 plus 0, 3, and 2 plus 2, 4. So it will be like 5, 3, and it will be 4. Okay, now this is done and this is done. So after P4, with this content of the work array, with this number of available resources, which process request can be fulfilled? So here you can see, if I go to this P0, I cannot complete the request because its need is greater than 1. For P1, it is over. Okay, I will go to P2, 600, again it is greater than this, so I cannot go with P2. Okay, P3, 011. Okay, it is less than this work. Okay, so I will complete the request of P3. So I will complete the request of P3. So I will say, okay, 211 should be added with 534. Okay, so if I add 211, it will be like 5, 3, 1, 4, 5, 2, 7. Now with 745, can I complete the request of P0, P2? So I can say 743, is it less than 745? Yes. Okay, so I can go with P0. So I will say P0. And after this, if I add 010 to this 010, I will get 7, 5, and 5. Okay, and after this P0 is over, I am having 755 as the work array content. Okay, so 600, that is P2, I can complete because 600, it is less than this 755. Right, so now I will add 302 to this. Okay, so 302 will be added and it will be like 7 plus 3, 10, 5, 5 to 7, 10, 5, 7. So finally my P2 is also over, 10, 5, 7. So here you can see, in the previous sequence also I got the same answer, 10, 5, 7. Here also I got 10, 5, 7, and I am able to complete the request of each and every process. Okay, so this is my another safe sequence, P1, P4, P3, P0, P2. So again, if you are able to find any safe sequence, that means your system is in safe state. Okay, so in this way you can find the other safe sequence also. Okay, so these are those safe sequences. So these are those safe sequences. Okay, we have found this safe sequence and we have found this safe sequence. Okay, you can just check by yourself whether you are able to find these safe sequences or not. Okay, so this is all about this video. I hope you have got the idea behind this banker's algorithm, or you can say safety algorithm. In the next video, what we are going to see? In the next video, we will be seeing resource allocation algorithm with the help of example, which is part of the banker's algorithm. And in the GATE and the other exams, the questions based on both these algorithms can be asked in the name of the banker's algorithm. Okay, so if you have any question, comment, suggestion, please write down into the comment box, and please subscribe the channel and press the bell icon for further notification, and do not forget to subscribe this channel. Okay, and share the video among your friend also. So see you in the next video. Till then, goodbye.